Okay, so we're going to review what we learned yesterday. Okay, any of you wanted to just volunteer and tell me, just make a recap of what we learned yesterday? Ning, do you try?
I wasn't
Or
here
did you?
yesterday.
Oh, did you watch the video though?
I watched some parts of it.
Okay. Um, okay, so let's recap then. First, in a periodic table, you're gonna have period and groups, right? Period going to tell you the number of shell. The group going to tell you the number of valence electrons. As you go to the right, the atomic number increases means number of proton increases. Whenever you are going to look at the size of the what? The size of the element or ions, it's best for you to write down the configuration first. Even though it's not necessary, of course, especially ions though. Okay, especially ions. You do want to write down the configuration first. When you do write down the configuration, you will see which shell, like how many shells do they have that are occupied. So for example, iron has 4 shells, while iron 2 plus and iron 3 plus, ferric and ferrous has only 3 shells. Okay? When iron has 4 shell, that means iron atom is the biggest of all. Okay? It is the biggest one. Compared to iron 2 plus, which only has 3 shell. Okay? And iron 3 plus, which only has 3 shell. So the biggest one is iron. Whenever you are comparing what? The size of an ion, make sure to write down the configuration. Okay? Even though it's just like a noble gas configuration. To compare the periodic trend, the first thing you see is the number of shell. The first thing you see is the number of shell. The one with the higher number of shell is going to be bigger in size. Okay? Now, if the number of shells are the same, for example, in iron 2 plus and 3 plus, because the number of shell is the same, you then go compare the number of proton. How do you know the number of proton? The number of proton will not change for an element. It is just the atomic number. The number of proton is not going to change for an element. It's just the atomic number. Okay? So, because iron basically are the same element, iron, the number of proton is 26. So again, number of proton is the same, so now you have to go to the number of electrons. The higher the number of electrons, the bigger is the size because of electronic repulsion. Okay, bigger size, higher radius, same thing. Okay? So when comparing between Fe2 plus and Fe3 plus, we see that Fe2 plus has higher number of electrons, so this is gonna be bigger because there is more electronic repulsion. Okay? So that's a recap of what we did yesterday. Now, we want to learn another periodic trend. Okay? For example, what is electronegativity? What is electronegativity? Anyone? I'm pretty sure some of you know. No? Sid, do you want to try?
Um, is electronegativity like is an element's ability to like attract electrons from another element through like bonds?
Correct. Exactly. That's it. Okay. That is the electronegativity. So for example, let's say you have hydrogen with fluorine. When we make a bond, right? When we make a bond, what's happening inside the bond? There is a sharing of electrons. So hydrogen and fluorine are sharing electrons here. Okay. Now, the question is the electron going to be exactly in the middle between hydrogen and fluorine? Or is it going to be towards one of them? The answer
It'll,
is that,
oh, I was just gonna answer the question.
so it's going to be
It'll be closer to one element than the other, in this case, fluorine.
because,
It's more electronegative, and meaning that it has a stronger attraction to the electron shared between them than hydrogen.
correct. So that is the definition of electronegativity, the ability of an atom or an element to attract electron in a bond. Okay, that is what? Electronegativity. The ability of an element to attract shared electron in a bond. Okay? Now, the most electronegative element in the periodic table is fluorine. You probably, when you were doing honors chem, you probably had seen Pauling's chart where they give you numbers for electronegativity. You're not going to get that in honors in AP Chem. Instead, you kind of have to know the trend. Okay? The most electronegative element in the periodic table is fluorine. Okay, so my trick that I like to use is that those who are closer to fluorine would be more electronegative. However, hydrogen has more similar electronegativity to carbon. So it's basically kind of around here, okay? Hydrogen sits around, you can say around here in position. So, which is more electronegative, oxygen or selenium? Look at how far it is. But this is not going to be your answer to reasoning. Which one is more electronegative? Why? Because it's closer to fluorine. No, that is not the reason. Okay? That is not the reason. That's just a trick. The reason, again, comes back to this. Okay, so this is going to work everywhere. Okay? So, let's see. We want to compare between, what was it again? Oxygen and selenium. Okay? Oh, maybe oxygen and carbon. Which is more electronegative? Now, again, think about this. Okay, what is electronegativity? The ability to attract electron. Actually, before we go about all of this, I want to talk about Coulombic force or Coulombic attraction. Who know what is Coulombic attraction? Or Coulombic force? The Coulombic force is basically charge times charge, QQ over R square. Okay, what are this? Well, basically the charge is the charge of proton. The radius is just the distance between nucleus and outermost shell. Write it down, okay, guys? Okay. So what do we have? Coulombic force is when you have higher proton number, the Coulombic force is going to be higher. When you have higher proton number, the Coulombic force is gonna be higher. Okay? It's kind of like magnet, right? Think about this, okay? So let's say you have two things that are charged. One is +1 and -1. The other is +2 and -2. And think about the distance are being exactly the same. Which one's gonna attract more? The one with higher charge, right? They were gonna have more Coulombic attraction. Okay? So higher charge means you're gonna have more Coulombic attraction. So between these two, you're gonna have, if the charge or number of proton higher, the Coulombic force is higher. Okay? Now about the distance. When the distance, let's say the charge now is the same, but the distance is different. Now, which one's gonna have higher attraction? The one, think about like magnet, which one's gonna have stronger attraction? If the magnets of opposite pole are closer or farther away? Of course, the one that is closer, right? So when you have a closer magnets, they're gonna attract more. So as the distance between nucleus and outermost shell decreases, the Coulombic force increases. Okay, so let's recap. The higher the number of proton, the stronger is the Coulombic force. The higher the number of proton, the stronger is the Coulombic force. The higher the distance, the weaker is the Coulombic force. Anyone wants to ask anything? So far makes sense? Yeah? Okay. Now, okay. Now, based on Coulombic force, again, as your Coulombic force increases, think about the Coulombic force being the force of the nucleus, okay? The attraction force of the nucleus. More attraction, the size gonna be what, Joey? More attraction, the size would be?
More traction would be a
The size would be?
big.
Hello?
Hello?
Yeah, more attraction, more Coulombic force, the size would be?
More traction would be smaller, right?
Because the attraction coming from the nucleus, right? If the nucleus attract everything, what's gonna happen? The size gonna be?
It's gonna condense.
Correct. Okay, so higher Coulombic force size would be smaller. What about the electronegativity? Anyone else wanna try? Ning? What do you think will happen to electronegativity as the Coulombic force increases? That's okay. You can try. We'll start from the very beginning. Yeah, go ahead. When we think about the Coulombic force being strong,
Does it become greater?
It's gonna become bigger, but why? I need to hear the reasoning.
I forgot.
That's okay. What is electronegativity? The ability of an electron to, the ability of an atom to, remember this one? The ability of an atom to attract electron. Think about if this one has like a superpower of its nucleus has superpower, strong attraction, strong Coulombic attraction. Okay? Think about when this has strong Coulombic attraction. That means the ability for it to attract electron will be higher. Do you see it? Electronegativity means they want to attract others' electron. And if the nucleus has more Coulombic force, there will be more attraction. Okay, makes sense? Yeah. Anyone still kind of like fuzzy on this? No? Okay. Now, so electronegativity would go up. Now let's talk about ionization energy. What is ionization energy?
Ionization energy is the amount of energy required to ionize said element or atom.
What do you mean ionize?
Ionize
What do you mean ionize?
to give it an electron.
To to release an electron, right?
Mm-hmm.
Yes. Okay. So think about this. Okay, please look at the diagram. I'm trying to make it more um I'm trying to draw more pictures so you guys can imagine like what's actually happening inside the atom. So let's say this is the atom, this is the nucleus, right? And these are the shells. Okay. Ionization and of course you have like multiple electrons. Ionization and whenever you want, look at this guys, whenever you want to take out an electron from an atom, that is ionization. Whenever you are trying to pull away an electron from an atom, you will need energy. Okay? Whenever you're trying to pull away an electron from an atom, you're going to need energy. That energy is known as ionization energy. So think about this. If this is the nucleus, right? This is the nucleus. If the nucleus already has a strong Coulombic attraction, guys, look at this. If the nucleus already has a strong Coulombic attraction, that means the electron in the atoms are held by strong attraction. So do you guys think it's easy to take out electron from the atom, or is it hard to take out electron from an atom if the nucleus has strong Coulombic attraction? If the nucleus have strong Coulombic attraction, is it easy or harder to take out electron from that, say, atom?
Harder?
It will be harder because the nucleus has strong Coulombic attraction, so it's hard to take this one out.
So I
When
have
it's
a
hard to,
question.
mm-hmm.
Does that mean that you could say something where like the ionization energy and the electronegativity of an element are kind of correlated? Like if it has a high electronegativity, it'll have a higher ionization energy required to get rid of an electron, and the opposite as well.
They are correlate because they all comes down to Coulombic force. They are correlate, but in AP test, you cannot explain one trend based on the other. Okay? If you explain one trend based on the other, you're not gonna get the point. So how do you explain? That's what I'm trying to teach you guys in this program. Okay? I have seen a smarter student get a 4 compared to a less smarter one get a 5 because they know how to explain, they know what to write on their FRQs. Well, MCQ is just like depending on how much you know the material, but FRQs, this year's FRQ, I would say that the last year FRQ was so hard. I don't know if you guys gone to Reddit. It's like everyone's crying on those FRQs. And what gonna make things worse is that there are gonna be things that you know for sure what's the answer gonna be, but your reasoning is not up to mark. So yes, they are correlate because they all comes down to Coulombic force, but you cannot explain ionization energy based off atomic radius or electronegativity. You always have to explain it based on the Coulombic force. Does it answer your question?
Yeah, it does. Thank you.
Okay. Okay. So yeah. Okay, so what we were saying. Okay, so when we have okay, go back. Okay. Ionization energy is the energy needed to take out electrons from an atom. When the atom that we're talking about has a strong Coulombic attraction, that means it's attract all its electron firmly, then what happened? It's going to be harder to take out the electrons. That means it's going to require higher ionization energy. Okay? It's going to require, but how would you explain? So for example, let's say we want to explain who has higher ionization energy between oxygen, or maybe magnesium and calcium. How do you explain? You're going to, again, go back to this. If you explain it based off this, you're going to get the full points. Okay? So first you look at the shell. You look at the shell, right? So you see, oh, calcium has what? Calcium has higher number of shell. Because calcium has higher number of shell, now you're going to go to the Coulombic attraction. Because calcium has higher number of shell, the distance between the nucleus and the outermost shell is higher in calcium. That means the Coulombic force is lower, right? And because the Coulombic force is lower, the ionization energy in the ionization energy, oops, this is high. Ionization energy, if you have higher, so the ionization energy will go lower. Lower Coulombic force, lower ionization energy. Okay, let's go back. What did we say? First, you look at the periodic table. Between magnesium and calcium, what do you compare first? This is how you compare, okay? First, you compare the shell. The shell itself, or the breaking point. Calcium has more shell, right? Compared to magnesium. More shell means the Coulombic, what? The Coulombic attraction will be lower. As the Coulombic attraction lower, because the what? The radius is lower, right? So the what? Ionization energy would go low. I'm going to actually make this one a little bit better. Instead of size, we're going to redo this one, but in terms of Coulombic attraction. So higher number of shell, the Coulombic attraction, Ca, okay, Coulombic attraction will go low. Higher number of proton, the Coulombic attraction would go high. Higher number of electron, the Coulombic attraction would go low. Because there is what? More repulsion, right? This one is because the reasoning, because the distance is more. This one is because higher number of proton. This one is because electronic repulsion. Now, once you have this, once you know the Coulombic attraction or Coulombic force, you can say higher Coulombic force, smaller size or radius, higher ionization energy, higher electronegativity. You guys said? So this one page is going to help you with all your, I would say 80%. We haven't gone through the exceptions yet. There's always going to be exception, but this is going to help you answering 80% of all the periodic trends question. with the correct reasoning. Okay, now let's test it out. Okay. Which one has higher ionization energy, sodium or magnesium? That's the question. Which one has higher ionization energy, sodium or magnesium? That's the question. And try to answer it based on this page. Make sure to write your reasoning and why and put it in the chat box. Sodium versus magnesium, which one has higher ionization energy and why? Make sure you talk about Coulombic force. Okay, first talk about this, and then talk about this. There are 8 of you guys. I need 8 answers, okay? Everyone participate. If you're not going to participate, there's no reason you're here. If you're just going to listen passively, that is just not gonna work. That's just not how it's gonna work.
It's between sodium and what other element?
Oh, sodium and magnesium.
Okay, yeah.
Which one has versus magnesium? Which one has higher ionization energy? You know, anyone here got like 97, 98% in their honors chem? How many of you got 97 or 98 or even above those? So last year I had like this student who got, she got 97% in her honors chem, and then she got into AP chem and she was crying. She was saying to me, "Oh, honors chem blindsided me. I thought chemistry would be easy. I thought AP Chem would be fun and easy. It is fun. It is fun. But it's not that easy. Okay, only 15% got a 5 this year. That is down 3%. So if you guys really want to do well, just make sure to start it right. Okay, let me see. Diksha, which one has more proton? Think about it. Read your answer again. Reasoning, guys, reasoning. I need reasoning. Why? Bhargav, you there? Good job, Pranit. Okay, how would we explain? Sodium versus magnesium. Look at this, okay? Okay, so first you look at the shell. Both of them have what? 3 shells? So this is not going to be your reason. You don't even have to mention this. That's not your reason, don't mention. Okay? Next, you look at the proton number. Which one is more? Which one is more? Diksha, which one is more? Who has more
Magnesium.
proton? Magnesium has more proton. What did we say? Higher proton. Ignore the size, okay? This was, okay. Higher number of proton means higher Coulombic attraction. Everyone please listen, okay? Magnesium has higher number of proton, therefore it will have higher Coulombic attraction. With higher Coulombic attraction, we're talking about what? Ionization energy? It will be harder to remove the electrons from the atom, so the ionization energy will be higher. That's it. This one page gonna help you. Okay, you can explain everything, but the more you explain, there is a chance of you getting it wrong. So try to just stick to whatever keyword you need to say. Okay, Coulombic attraction or Coulombic force, the number of proton, higher number of proton, higher Coulombic attraction, therefore ionization energy is higher. That's it. Or if you want to talk about like it's hard to remove electron, that's better too. Okay, let's try another one. Which one has higher? Which one has higher electronegativity, fluorine versus chlorine? Go ahead, everyone. Put it in the chat box.
Could you scroll up to the periodic table real quickly?
Okay. Chlorine and chlorine.
Thank you.
Joey reasoning. Which one has higher electronegativity?
When you're talking about the shells, what would you call it? Would you call it a one extra valence shell, or what would you call it?
Don't call it valence shell because everyone's going to have one valence shell. Valence itself means outermost. You can call it shell or you can say principal energy level.
Okay.
Vivan, you are not allowed to explain one trend based on the other trend. The size is one trend. You cannot explain the size, you cannot explain electronegativity based on size or any other way. Like this cannot be explained, okay? Try again. You want to explain based on Coulombic force. Again, Bhargav, same thing, okay? Do not talk about the radius. You're almost there. It's just you mentioned the radius. That means you are mentioning other periodic trend. That's not acceptable. Same goes Joey. Just talk about the distance. Okay, if you guys kind of like, oh, how do I talk? It's not size. You want to talk about the distance between the nucleus and the outermost shell. The distance, that's the keyword. Distance between the nucleus and outermost shell, not the size, not the radius. Do not use those keywords. It's kind of particular. That's the thing. I keep saying. It's not the smartest one always gonna get a 5. Sometimes the less smarter one get a 5 compared to the smarter one. Okay, good job, Diksha. Good job, Sip, but you also want to mention the Coulombic attraction. Okay? Good job. Very good. I feel like all of you kind of get it now, what they're looking for. Okay, any questions? So basically what we're gonna say, fluorine has higher electronegativity compared to chlorine because it has more, or you can say extra shell, or extra PEL, principal energy level, compared to chlorine. Because of this, the distance between the nucleus and the outermost shell in fluorine is lesser, causing a higher Coulombic attraction. And because of that, the electronegativity would be higher. Okay? Okay, so let's try. Give me a second, let me think. Oh, we were talking about ionization energy. Oh no, that's fine. Okay. Nitrogen versus sulfur. Which one has higher ionization energy? Okay, good job, Pranit. Nitrogen versus sulfur, which one has higher ionization energy and why? Reasoning. Good job, Bhargav. Very good. That's how you should answer. Okay, that's how you get full point. But however, Bhargav, the question was higher ionization energy. You were answering lower ionization energy. You also gonna lose point there. The AP test is very particular. But Vivan, you did not explain why it has higher Coulombic force. You did talk about the Coulombic force. You did talk about this part, but you didn't talk about either one of this part. Okay, good job, Vivan, to talk about the shielding effect, which we're gonna learn later if you guys join my program. Joey, we talk about this. You do not talk about the size or other trend to explain the other trend. We are asking for ionization energy. Make sure not to talk about the size or the electronegativity. Okay? Ning, you too. You cannot talk about the radius. Radius and size is another trend. You cannot explain one trend. If you want to talk about the distance, you say exactly that the distance between the nucleus and the valence shell, even though it doesn't make sense. Isn't that just the radius? That's just how they want. Okay, I know they are very particular. If you want to get the full point, you just have to follow what they want. Okay, so you cannot talk about radius or size. You have to talk about, if you want to talk about the distance, talk about the distance between the nucleus and the outermost shell. Okay, Ning, let's do it together. So how do we explain fluorine versus chlorine? You already wait, sorry. Nitrogen versus sulfur. Which one has higher ionization energy, you said? Nitrogen, because first we look at the number of shell. Do they have the same number of shell or no? Ning. Nitrogen versus sulfur, do they have the same number of shell or different number of shell? Which period they are at? Nitrogen is in which period? Nitrogen is in the second period, so how many shell it has? 2. Sulfur is in the third period, it has 3. So sulfur is what? Farther away. The nucleus is farther away. The valence shell is farther away from the nucleus in sulfur. So you're gonna say, because sulfur has more number of shell, the Coulombic attraction is lower in sulfur, right? Or you can say, because we want to say which one has higher ionization energy, because nitrogen has less number of shell, right? So the Coulombic attraction is higher in nitrogen. With a high Coulombic attraction, the ionization energy is also more compared to sulfur. That's it. Okay? Does it make sense? Yeah? Okay. I think that's it for today. Do you guys have any question? Maybe about the AP test or anything that you want to ask? Because today's our last day. Also, I really hope most of you are going to join my full program because, see, AP Chem is not easy. you guys will understand once you go into the school year, but it's not easy. So if you start it the right way, it's going to help you so much. Okay. And yeah, any question regarding the AP test or no? Okay, then that's it for today. Just make sure to review everything that we learned, especially in these 2 days, okay, about the periodic trend, because this is like the first unit, the periodic trend. And if you get the periodic trend correct, and most of it is gonna come into your FRQ question because they like to ask you reasoning. We didn't talk about the exception though. We will in the full program. Okay. But yeah, that's it for today then. Bye-bye.
Bye, ma'am. Thank you.
Thank you.
Okay.